Hi everyone, this is a help video on 1.1 rules for exponents and radicals. Over on the left side here I have my Delta Math assignment. It has 4 different categories right here, 1, 2, 3, 4, and each one has 5 problems in it, so you get some good practice in here. None of these problems are difficult, but you will have to remember your exponent rules, and there's this handy little cheat sheet, and it's on both CTLS and on my blog. Okay, so we're going to look at exponents here. All right, and we have exponential rules. Let's get to our first problem. Our first problem says 10b to the 6th over 5b cubed, or to the 3rd power, and take that to the 3rd power. All right, so we've got 2 different things in here. All right, one, we have the power rule. All right, the power rule. All right, and then we also have, since this is division, remember division, that cool word quotient. I don't know why I like it, but it's a cool word. We also have the quotient rule. All right, so let's look at the power rule. All right, so over here on our handy little slide, we can see the power rule says if you have an x on the inside and a y on the outside, you multiply them, it becomes xy. All right, so we're going to use that rule here. Okay, but the first thing we have to do is remember that this is going to be 5 to the 3rd power and b to the 3rd power. To the 3rd power. Okay, so we can't ignore that 5. If we just put that 5 down there, that wouldn't work. All right, so 5 to the 3rd power is 125. If you don't know that for sure, you can put it in a calculator or multiply 5 3 times, you'll get 123rd. All right, then this says 5 to the b, and it says multiply these two. So that's going to be 3 times 3, which equals 9. All right, so that means my denominator looks like this. 125b to the 9th power. All right, on the top we have b to the 6th power. All right, so now we look at our second thing, which is our quotient rule, and here it says when we're dividing we subtract. All right, so when we divide, we subtract. All right, so we have a 6 and a 9 here. All right, so we have to look at this in 2 separate ways. You have to kind of draw a little line in the middle here. All right, and you have to handle the numbers separately. All right, so you got to simplify the numbers and simplify this side. Well, this side's going to be relatively easy. It's going to be b to the 6 minus 9. All right, and that gives us b to the negative 3rd power. Boy, we have to go back to our notes again. It says if we have a negative power, it's the same as 1 over the number. So it's the inverse. All right. Okay, so that is going to be equal to 1 over b to the 3rd. All right. Now we go back over to our other side, and it looks like we can take 5 out of each one of these. 5 times 2. And 5 times 25. 5's cancel out. So at this side we simplify to 2 over 25. And now we have 2 over 25 times 1 over b to the 3rd. That's 225b to the 3rd. Boy, for our first problem, that was kind of a crazy one. All right, but here we go. So we're going to say 2. And then if we say divide, it gives us a fraction right away. All right, we're going to say 25, 25. We have to go find a b. We go back, and we want a power, and it's 3. Okay, and we're going to say submit answer. And that looks like my answer over here, so I'm going to say yes. and we get a check mark. All right, so that was a lot of different things to do in that one, but I encourage you to give those a try and use these answers over here. All right, now we're going to simplify radicals. Say erase all, and simplifying a radical. Well, these are pretty simple, really. All right, so you're looking for, look for perfect squares. Now, if you don't remember what the perfect squares are, all right, they're 2 times 2, 3 times 3, 4 times 4. Okay, so they're 4, 9, 16, 25, etc., etc., etc. All right, so now you're looking in here, and you're looking to see if any of these perfect squares are a factor in here, and I think 25 is. Okay, so we could write this as 25 times the square root of 3. All right, and maybe just for clarity, let's do this. We can write it as 25 times 3, and then we can take each one of these and make it a separate radical, 25 times 3. All right, and then we take the square root of 25, and that equals 5, and we bring this down, and we get the square root of 3. All right, so let's put that in. We get 5, square root of 3, submit answer. Yes, that's what it is. All right, and so here they showed you that they kind of went through the same thing. 25 goes evenly. All right, simplify radicals with an x. It's based the same sort of idea that we have here. So we have x to the 4th and the square root of x to the 5th. All right, so what you want to do here is take the highest even number for the exponent. All right, so this is 5. All right, so the highest even number inside of 5 is a 4. All right, so that's our first step, is take the highest even number. If it's an even number, you're already okay. All right, and so we're going to take x to the 4th, and that's going to leave us with 1x. All right? Now, the next thing we do is we say, oh, x to the 4th is actually equal to x squared times x squared, so we can bring that to the outside. So this is going to say x squared square root of x, and don't forget about our other x to the 4th. All right, now we have to go back to our rules of exponents. The product rule says when you multiply exponents, you add them. All right, so we're going to have x to the 4 plus 2, which is the same as x to the 6th square root of x. Okay, there's our answer. All right, so let's see, x to the 6th square root of 6. Awesome. Submit answer. Make sure that's right. Yeah, we're really sure that's right. Okay. All right, so that's those problems. You notice they did it the same way I did. They picked the highest exponent, even number. If you have an even number on the inside, you're awesome there. Okay, and adding radicals with x. All right. Adding radicals with x. Okay, so the first rule is to add radicals. Okay, the radicals have to match. Okay, so if we were going to say add the square root of 2 plus the square root of 128, well, we can't do that because the radicals aren't the same. This one's a 2 and this one's a 128. So the first thing we have to do is try to change this 128 to a 2. All right? So that's basically the rule that you're talking about here. All right? Okay, so we have x to the square root of 2 cubed and minus 4x squared, 128x. Holy cow. All right. The first thing I notice is that we can simplify this one by making it x squared times 2x. All right, so I took the highest even number out of there, which was a 2. All right, and that looks like that. And so then we have x times x squared times 2x. And the square root of x squared is x, so we have x times x. And that gives us an x squared times 2x. All right, now we have to change this into somehow to get this to look like 2x if we want to add it to this one. All right, so the first thing we're going to do is we're going to find out what is 128 divided by 2. That is 64. All right, so that means we can take this 128x and change it to 64 times 2x, or 64 times 2x, and the square root of 64 is 8. So now this looks like 8 times 2x. All right, now we bring this other thing down here, and so we have minus 4x squared times that. All right, so we multiply these two together, and we get minus 32x squared over 2 times 2x, and oh man, and now we have x squared. Okay, so we have 1x squared here, and we have 32 there, so that's going to be a minus 31x squared and 2x. That was a lot of work. Minus 31x squared, square root of 2x. Boy, I hope my answer's right. Oh, it was. Otherwise I would have had to redo it. Okay. After doing this, I'm going to go back and change these because some of these are really long, so you don't have to do 5 problems in each one. Anyway, so I'm change that to 2 problems and change this one to 1, so it'll be a lot easier for the number of problems. Okay? So if you have any questions about that, you can text me or check the blog. Anyway, there you go.